frequently we need to answer a question: should we decrease or increase the prices of our product? In order to answer this question, we need something we call elasticity. Or more specifically, price elasticity of demand. Okay, what do I mean by elasticity? Essentially, I want to know, say, if price changed by 1%, say if price increase by this percentage, say change in price over price, so that's a percentage change. What percentage will the quantity of demand change? And by the way, we know that price increases, quantity decreases. So we know that this elasticity is always negative. This price elasticity of demand is always negative. So sometimes we ignore the negative signs because we know it is negative by law of demand. Okay, so elasticity, this epsilon, this denotes the elasticity, price elasticity of demand, is say how many percentage change of quantity over this percentage change of price. Okay, this multiply both top and down by price, so this cancels out this. Then multiply both top and down by quantity, so this quantity cancels out this. So we can reduce this will be dq over dp times P over Q. And these terms this is the slope of demand curve. Demand function. Okay, and this is price. So we, by looking at this formula here, this price elasticity of demand actually depends on three factors: the slope, how steep or how flat the demand curve is, and the positions, what's the price, what's the quantity. Okay, let's look at the demand function, demand curve. Q. So we know that demand curve looks like this. So that's demand, or actually more accurately, I should say, is inverse demand, because we put the price on the vertical axis, quantity on the horizontal axis. So more accurately, it should be inverse demand. So the slope of demand curve will be just 1 over the slope of inverse demand curve. Okay. So we know that the demand function or linear demand function look like this, and we can capture this by a mathematical equation. Q is equal to A minus BP. Okay, A is some parameters, and B is another parameter. B is the slope, and A is what we call intercept. Okay, for example, a demand function could be could be Q is equal to 10 minus P. Okay, and let's draw, suppose the demand function is, let's draw it on the PQ space here. And we know that Q is, quantity is a linear function of price. Okay, so it's a straight line. All we need to do is we can find 2 points to pin it down. If we find 2 points, we can pin down the whole line. Okay, so the first point, let's say P is equal to 0. What's Q? Q would be equal to 10 minus 0 is 10. So P is equal to 0, Q is equal to 10. 10 here. Second point, let's say Q is equal to 0. What's the associated price? So let's work it out. So Q is 0 is equal to 10 minus P. So this implies that P is equal to 10. So it's 10 here. And now we have these 2 points. Let's link them together. So that's the inverse demand curve. Okay. So this is the demand curve. Where quantity is a function of price. So we can also write this as an inverse demand curve. Okay, so hopefully this won't confuse you too much. So inverse demand curve or inverse demand function. So we will write price as a function of quantity. Okay, so what we can do is, let's move this price to the left hand side and quantity to the right hand side. So that becomes P is equal to 10 minus Q. Okay, that's inverse demand curve. Okay. Okay, so now we have this inverse demand curve. P is equal to 10 minus Q, or demand curve Q is equal to 10 minus P. Okay, let's calculate the elasticity at different points on this curve. First point, okay, let me label some point here, A, B. Okay, at point A, so what's the price elasticity of demand? So we know that this is change of quantity over change of price times price over quantity, right? And this sometimes usually we are going to replace the delta here. Delta is change, simple change, by dq over dp times p over q. So now we change the delta to d. So this actually is differentiation. We can use the calculus tools. Okay, but if you are not comfortable, that's fine. So just take this as given. So this is slope of demand function, or one over the slope of the inverse demand function. Okay. So at point A, the price elasticity of demand is called epsilon A. So dq over dp, the slope here is -1. Okay, so for linear function, q is A minus b times p. Then the slope is dq over dp, so it's equal to -b. And it's negative because it's downward sloping, and we can frequently ignore these negative signs, which is fine. So it's -1 in our case here, times p. At point A, p is equal to 10. Q is equal to 0. So now here we run into some sort of mathematical dilemma. So we are dividing something by 0. That's not defined mathematically. So we got to think that we are dividing something that approaches 0. Okay, so this becomes infinity or negative infinity. Okay. Let's ignore negative sign. So we are dividing something by a very small number. So at point A, that's the price, that's the demand. At B, the price elasticity of demand, again, is the slope, which is negative 1. Okay, we know that. Times price at B is 0. Quantity at B, point B is 10, so it's 0. So from A to B, we see that the price elasticity of demand decrease from infinity down to 0. So at some point there, in the mid, not necessarily in the middle, but at some point between A and B, let's call it C. At this point, the price elasticity of demand will be equal to 1. Okay. And the segment on the segment AC is elastic because price elasticity will be bigger than 1, so elastic. And on the segment BC, this is price elasticity of demand will be less than 1, so it's inelastic. Okay, that's price elasticity of demand. Right, but I haven't answered whether I should cut my price or increase my price. Cut the price of my coffee or increase the price of my coffee. Okay, suppose this is demand for coffees and I'm running a coffee shop. I'm faced with this demand function. Okay. So now let's answer this question. So I care about revenue, right? Total revenue, which is the price times quantity. So I produce 100 cups of coffee every day, so at the price of $5. So total revenue will be $500. Okay, now I'm going to think, should I cut the price from $5 or not? So if we cut price, price decreases. No demand will say, because price decreases, quantity will increase, right? So now, in the end, our aim is we want to increase this revenue we can make out of selling these many cups of coffee. So these two are, so if we cut price, quantity can decrease, but price decreases. Despite the quantity can increase. So we want to see, now we want to check which one dominate which one, right? So that's our demand function. So let's look at total revenue as a function of quantity. Okay, if I charge a price of this many or higher than these levels, this 10, okay, in my example here, then nobody will buy my coffees. My total revenue quantity of demand will be 0. So total revenue will be 0. So it's 0. So at this point, starting from A and go down to B, and there's a C here, where if the price elasticity demand equal to 1. Okay, starting at point A, the corresponding point A on the total revenue quantity curve space is this. Okay, starting from point A, I'm going to say, okay, I'm going to cut my price by 1%. So price decreased by 1%. Price decreased by 1%. Quantity of demand increased by epsilon percent, right? Because that's what we mean by elasticities. Okay, quantity will increase. And this, so on AC part, epsilon is bigger than 1. On the AC segment, epsilon is bigger than 1. So this is bigger than 1%. So now we have 1% decrease in price. However, we have more than 1% increase in quantity. So total revenue increase. So total revenue increase to this point. This point. Okay. And at this point, let's keep going. Say, reduce another 1%. Reduce the price by another 1%. And because again, demand, we are on the elastic segment of the demand function. So quantity of demand will increase by more than 1%. So we reach this point. So total revenue keep increasing until we reach point C, where price decreased by 1%. However, the quantity is actually increased by 1%. So they cancel out. So we reach this point. And if we keep going, at point C, let's keep cutting the price by another 1%. Then quantity of demand for my coffee will continue to increase, but now we get into an elastic segment of the demand function. So the increase in demand will be less than 1%. So it starts decreasing now. So this one. Keep going until we at B, until we reach B. At B, well, we are charging a price of 0. So coffee is free. So total revenue will be 0. Let's link all these terms together. We get a total revenue as a function of quantity. And now to answer our questions, should I cut the price or not? So essentially, if our aim is to increase the total revenue, then if we are on the okay, let me just erase something. So our aim to increase total revenue. Then if demand is elastic, should cut price. If inelastic, actually we should increase the price so that we can improve our revenues. Alright, so this is about the price elasticity demand. And it measures how sensitive the quantity of demand respond to the price change. And certainly there are other types of elasticity as well. An example would be income elasticity of demand, which can be defined similarly. So percentage change of quantity over percentage change of income. So this is income. Alright, that's all for this topic.